Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! If we put this in a place value grid, and so we've got thousands, hundreds, tens, and units. We've got 9, 0, 8, 8. So it's 9,000, because it's 9 lots of thousands, and 8 tens, so it would be 80. And we've got 8 units, so 8. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in twos, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be 1 high, because they're going up in twos. And we need a way of showing male or female, so what I'm going to do is just shade the female there, and I'm going to just draw a key. I'm going to say if it's not shaded, it's males, and if it is shaded, it's females. Okay, next we're going to do the 8 and the 4. So what you can do is just do the whole thing, and split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. If there were 39 people on the bus and 4 people got off the bus, that would leave 35 people remaining on the bus. So the fraction of people staying on the bus is 35 out of the 39 people on the bus. So our answer is, as a fraction, 35 over 39, and we can't cancel that any further. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get 3 integers or whole numbers and we multiply them by themselves 3 times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. So what this means is that the width is between 1 and 2. So we're going to look at our list and see all the widths that are between 1 and 2. This bit here means it can equal 1. This bit here means that 2 would go to the next group. So we've got 1, 2, 3 numbers that are between 1 and 2. So the frequency will be 3. This next group says between 2 and 3. So this will be 1, 2, 3, 4, 5. Then we've got between 3 and 4, just this one here. And then between 4 and 5, we have just the 1. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. To find a fraction of amount, what we do is we divide by the bottom of the fraction times by the top. So we're going to do 60, and we're going to divide it by the bottom of the fraction, the denominator, which is 3. And 60 divided by 3 is 20. Then we're going to do 20 times 1, which will just remain 20. So our answer is 20 kilograms. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. To compare fractions, you've first of all got to make sure the denominators are the same. So we've got to find the first number that is in the 3 and the 9 times table. If you start doing the 3 times table, you notice that 9 is actually in the 3 times table. So we need to convert these both so they're over 9. Well, we don't have to do anything with the second one, but for this first one we've got to times top one by 3. So we're going to times top one by 3 and we get 6 over 9. Now it's asking for which one is the larger. Well, 6 over 9 is going to be the larger because 6 is bigger than 5. So you just compare the numerators. But don't write 6 over 9, we've got to write the original question, which is 2 over 3. We're going to start just by copying out the question. Now when we're asked to solve, it means we need to find x, okay? And I'm going to start by putting in my solving lines, which are just lines to the left and right of the equal sign. And what we need to do is get x on its own on the left-hand side. Well, what's stopping x from being on its own? We've got this 12 here. Well, what's that 12 doing to the x? Well, it's timesing it by 12. So we need to do the opposite of that to get rid of it. What is the opposite of times 12? Divided by 12. Now these lines show us we've got to do the same to the left and right. So if I divide the left-hand side by 12, I have to divide the right-hand side by 12. So on the left-hand side we just have the x, which is what we want. On the right-hand side we do 36 divided by 12. How many 12s in 36? That would be 3. So our solution is x equals 3. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. To be able to add or subtract fractions, we must make the denominators the same. So what we do is we write out the 5 and 7 times tables. So 5, 10, 15, 20, 25, 30, 35. And you keep going through each times table until you get to a number that's the same in both. You can see it's 35 here. So we're going to times top and bottom by something to make the denominator 35. So for this first one it's going to be 7. So we're going to times top and bottom by 7. For the second one it's going to be 5. So 2 times 7 is 14. and then the bottom will be 35, the denominator. And then 2 times 5 is 10, and the denominator will be 35. Then when we have that, we take away the numerators. So 14 take away 10 is 4, and that just leaves 4 over 35. So we can see whether we can cancel it, and we can't. So the answer is just 4 over 35. To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21, and multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44, so it's 21 over 44 is our answer. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And a nice easy one to start off with is 10%. And we're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. And 1%, we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20%, we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240, we need to add the 50.4. Probably, again, don't need to show the working out for this, we can do this in our heads, but it's a bit easier to see what we're doing. So the answer would be 290.4. So to do this question, you just need a piece of paper, a ruler, and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on, will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here, and I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here, and I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out, and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. So I think about ratios as piles of money sometimes, and here we've got J getting 5 piles of money and Anne getting 4 piles of money, and each pile is going to be equal. So we've got to first of all work out how many piles of money there are. So we just add the 5 and the 4, so there's 9 piles of money. We sometimes in maths call them parts, so we say that we have 9 parts, okay, or 9 piles of money. Now, each part, oh, I've got an equals there, each part, or each pile is going to be worth what 99, okay, which is the total amount of money, divided by how many equal piles we have. So divided by that 9. So 99 divided by 9 is 11. So one part is worth £11. So J has 5 piles of £11. So J has 5 times 11, which is 55. And Anne has 4 piles of that money. So 4 times 11, which is 44. We can check this by adding the two together, and it should add up to the amount of money we have, which is 99, which it does. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4, and that will be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give you the right answer. In fact, there's a couple of different methods that you can get the same answer with. So we've just got to go around this two-way table, filling in what we can. So if we look here, the total amount completely is 25, so it's 25 students, and the total who said yes is 17. So if we take the 17 away from the 25, that leaves us 8. So 8 must have said no. Then same thing with here. There are 17 in total who said yes, 12 picked salad, and so therefore we take the 12 away from the 17 and we get 5. And so the total for the pizza will be 6. And then 6 plus 19 is 25, so we've got this bit along here. And then 12 plus 7 is 19, and we can check that as well. 1 plus 7 equals 8, so we know we've got it right. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. To work out the area of a circle, we first of all need to work out what the radius is. Now the radius is half the distance of the diameter. So to work out what the radius is, we get the diameter and we halve it, which will be 15 centimeters. So the formula for the area is pi times r squared, or pi r squared. If we know the radius is 15, it will be 15 squared. 15 squared is 225. And the way we write this is we put the number first and then we just put pi after it when it asks us to leave it in terms of pi. So it'd be 225 pi. Now the reason why we would do this is if we want to keep all the precision, we can do it in terms of pi so we don't have to round it. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay, now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4. So it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one. Ends up here. So if we join these up, and we need to label it B. Now, between A and B, the shapes haven't changed size, so it's not an enlargement. They haven't rotated or they haven't mirrored, they've just moved. And the word we use for that is translation. So this has been a translation. And for a translation, we need to find out how far right they've gone and how far up they've gone. So we pick a point that we know on both shapes, and I'm going to pick the top left, and we count how many jumps we jump to the right. So 1, 2, 3. So we do 3 jumps to line it up with the other one. So there's a 3 at the top to say 3 to the right, and then we count how far up we have to go. So 1, 2, 3, 4. Now we've actually had to go down, and whenever you go down, it's like having minus up. Okay, down is minus up, so it's going to be minus 4 because there were 4 jumps. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long. and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's a million. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. Now the rules of indices say that when you've got two numbers of the same base and you divide them, and the base is the big number here, the 11s, right? And you divide them, you take away the powers. So we're going to do 11 to the power of 21 take away 14, which is going to be 11 to the power of 7. So our answer is 11 to the power of 7. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the 4th term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3. Just keep going till you get to 39. Or we can do the method we've just done, which is solving it. So the first term will be 50 to the power of 1. Anything to the power of 1 is just itself, so that will just be 50. The next one will be 50 squared. So that's going to be 50 times 50, which would be 5 times 5 times 10 times 10. 25 times 100, which would be 250. 2,500 even. And then last one is 50 cubed. So that's going to be the 2,500 times 50 again. And so when you times that out, you get 125,000. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9. And then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. We know all lines follow the y equals mx plus c if they're linear. And we know that m is the gradient, so the coefficient, the number before the x is the gradient, and the number on its own at the end is the y-intercept. So looking at this equation, the y-intercept will be plus 5, because that's the number on its own at the end. So we're going to plot that straight away, because we know it's going to be at 5. So it's going to be there. We also know that the coefficient of the x is minus 2. Now what that gradient means is for every 1 we go to the right, we're going to go down 2. So if we go 1 to the right, it's going to be down 2 from the 5, or down 2 from the 5 will be 3. And then if it goes another 1 to the right, it will go down another 2. So that would be 1. So it would be at 3, and then at 1. And so if we draw that in, draw the full line in, we need to make sure we do it for the full graph, so make sure you have all the points. It should look something like this. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the graph, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a plus 24p. And 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3. So we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted, and 780 times 3 is 2340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a, 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of A, we know that A is a pound, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So this says find the probability of A or B. Now A or B means it can be in A, it can be in B, or it can be in both. So we add the 5, the 3 and the 12 together, and that gives us 20, and put that over the total amount. So that is these 3 added together, which is 20, plus the one outside here, which is 30. 20 over 30 is the same as 2 over 3. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the centre X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. It'll be x to the power of 16, and then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.